Alright, hi everyone. So today we're going to go on to the pH of a solution, or first of all, we'll start off with the pH of a substance. So when we talk about the pH, right, we are trying to look at the measure. We're basically measuring how much or how acidic or alkaline a substance is. Okay, so right now we're learning about acids and bases. So we're just trying to find out what is their pH. The pH scale ranges from 0 to 14, where anything that is between 0 and 7 is considered to be acidic. So you know your sulfuric acid and your hydrochloric acid, those will basically fall within a pH range of 0 to 7. So if you were to actually test the pH, it'll be between 0 and 7 for your acids. Anything that is basic, or your bases, your potassium hydroxide, your sodium hydroxide, they will have a pH between 7 and 14. And then at exactly 7, that is considered neutral, right? So we're saying, okay, cool, we've got acids, we've got bases. We can basically test their pH, and anything between 0 and 7, acidic. Anything 7 to 14, that is basic. Sometimes you can even calculate, not even sometimes, most of the time, you can actually calculate the pH yourself. If you're the one doing this lab experiment, you know the concentration of your acid, you know the concentration of your base, you can actually use this formula to calculate the pH. Now I'll break this formula down for you, right? So pH, that basically represents the pH that you're trying to find. Another thing I want to add on, guys, pH has no SI unit. So you know how we say something that's a mass is in grams or kilograms, concentration is in moles per cubic decimeters, volume is in cubic decimeters, but pH has no SI unit. It's literally just a number. So you can calculate the pH of a substance by using this formula, where if you put it in your calculator, you can say negative log, and then this is for the concentration of hydronium ions, of which I'll explain now. So don't let these brackets confuse you. So those basically stand for concentration, right? So since it is the H3O plus that is in the brackets, it basically means you have to punch in your calculator, you have to put a negative log, and then this, in that place, you can put the concentration of your hydronium ions. Same here. This is the concentration, so those brackets stand for concentration. That is the concentration of your hydrogen ions, right? But we know that these two are basically the same thing. Acids and bases, same thing, right? Now, I want to give you guys some examples. So here, if they say, what is the pH of hydrochloric acid that has a concentration of 0.5 moles per cubic decimeters? First thing, I want you guys to always remember that when you're dealing with pH, you have to think of the fact that acids ionize and bases dissociate. So if we're looking at HCl here, and we were to write the formula or the reaction for how HCl ionizes, we would see that HCl becomes 1 H plus ion and Cl minus, right? So basically this HCl here would break up into a hydrogen ion and chloride ion. Okay, that, think of ionization as breaking up, right? Your molecule or your compound will break up. So if you look at how HCl breaks up into H plus and Cl minus, and we're saying we've got a concentration of 0.5 moles per cubic decimeters of your HCl. Now the question would be, but we need to find what is the concentration of the hydrogen ions inside of that HCl, right? Because we've looked at how it breaks up, and now we can see it breaks up into a hydrogen ion and chloride ion, but how much of your hydrogen ion is inside that HCl? So here you can do, you know how we do mole ratio usually, where we say the ratio of sodium hydroxide to the ratio of HCl, and we say 1 is to 2 or 1 is to 1. That is the same situation here. You can actually do a concentration ratio, right? Where if you look at your formula that you've written in terms of how your hydrochloric acid ionizes, the ratio is 1 is to 1, which means this would be the ratio of hydrochloric acid to the ratio of your hydrogen ion, and if you check, it's 1:1, meaning if your concentration is 0.5 for your hydrochloric acid, then you can find how much concentration of hydrogen ion you have. You do a cross multiplication and you'll find that the concentration of your hydrogen ion is also going to be 0.5 moles per cubic decimeters. Now remember the formula for pH? pH is equal to negative log H plus. Remember I said these two brackets basically stand for concentration? Now that is where we put in our value for the concentration. So you put negative log 0.5 because that's your concentration. And then if you punch in your calculator, you'll see that you'll actually get a value that is less than 7, which makes sense because this is an acid after all. We get a value of 0.30. And remember, there's no SI units for pH, so it's literally just 0.30. And we said that acids have a pH that is less than 7. And this is less than 7. And this is an acid, right? So I'll give you guys another example. Now, they say, what is the pH of H2SO4 with a concentration of 0.125 moles per cubic decimeters? So same situation, right? We need to calculate pH by saying negative log H plus, right? So we need to know in this H2SO4, what is the concentration of the hydrogen ions in that H2SO4? First step, write the ionization process. H2SO4 would ionize and become H plus, but 2H plus, and a sulfate ion. As you can see, basically it is going to break up into an H plus and another H plus and a sulfate ion. That is the ionization process. Now, if we're saying our concentration for H2SO4 is 0.125 moles per cubic decimeters, now the question would be, what is going to be the concentration of your hydrogen ions? And you can do a concentration ratio, where you can say the concentration of H2SO4 to the concentration of the H plus. Basically, what is the concentration of the hydrogen ions inside of your H2SO4? And the ratio here is 1:2, right? 1:2. And we're saying we've got 0.125 here. So what would be the concentration of your H plus? And if you do a cross multiplication, you'll find that the concentration of the H plus inside of your H2SO4 would be 2 times 0.125, right? So there you can then get the concentration, and it would be 0.25 moles per cubic decimeters. And once again, you guys know the formula for pH, right? We said its pH is equal to negative log H plus. We found the concentration of our hydrogen ions, right? For both of them. That's why we were doing ratio. We found that, cool, there's 2 hydrogen ions that will come from that H2SO4, and their concentration will be 0.25. And that is what you then punch into your calculator over there. Right, so you put that into your formula, and now you can calculate your pH, which will give you a value of 0.60, which makes sense. Once again, pH needs to be less than 7. It's an acid. Right, so every time you need to calculate pH, the first step you need to go through, guys, is obviously we know the formula, we know how to write it down, negative log H plus, but now the question would be, but how many hydrogen ions are inside of that acid, right? So then you write the ionization formula. I'm very big on making sure that you guys write the ionization formula so you can see it for yourself and see that from H3PO4, we end up getting 3 hydrogen ions, okay? So there, if they tell us the concentration is 0.26 moles per cubic decimeters, all you do is a concentration ratio. And your concentration ratio here would be 1:3. And we're saying, okay, we know that the concentration is 0.26 And now we can find what is the concentration of the hydrogen ions. So 0.26 multiplied by 3, you'll see that the concentration of your 3 hydrogen ions, or your hydrogen ions inside of your H3PO4, sorry, I'd made a mistake there, you will see that it is going to be 0.78 moles per cubic decimeters, right? And once again, you go and you put that into your formula over there, and you'll get the pH. All right, so every time, guys, first step, always write down the ionization process to actually see how many hydrogen ions will come from that. Don't go straight to assuming that, oh, because my concentration for H3PO4 is 0.26, therefore my hydrogen ions will also be 0.26. This value that you put into the formula, this formula clearly states that it wants the concentration of your hydrogen ions. So you don't just put the concentration of your acid there. You need to actually find out by doing concentration ratio how much concentration of hydrogen ions you have in your acid every time. Okay, concentration ratio is very important.